All right, so this afternoon, after the heavy lunch, I hope you don't fall asleep, we're going to talk about site inspections and record keeping. All right, so what I'm going to talk about this afternoon is first just some general things. I'm going to talk about who should be doing the inspections, the inspection itself, frequency, corrective action, which we touched on in a couple of presentations, record retention, and then any special circumstances that you run into. All right, so in general, why are we even doing this? What's the point, right? What do we care? Well, we care because we need water to survive. And if you want to look at it in a practical sense, turbid water, which is what happens to water when sediment gets into it, is harder to treat for drinking water. You like to fish. Some people like to fish. My son likes to fish, and in fact, that's his first fish right there. It's almost as big as he is. He got that in Broken Bow. We want to keep the waters clean so that we can have fish to pull from the water, so we can recreate at the water, so we can enjoy the scenery. When you go out to do inspections, your most important thing to realize is that you need to be safe. So that includes wearing your proper protective equipment, if you need a hard hat or steel-toed boots. Watch what's going on above your head. Watch the speed limits. Bob Gigger, up in the back, actually got to see somebody, sadly, get clipped by a car. So it's really important. Okay. So why do we do site inspections? Well, you want to make sure that your BMPs are properly installed and they're effective. You know that BMPs can be damaged by actual rainstorms or other types of weather events, snowstorms. They can also be damaged by construction activities. You know, Joe was talking about enjoying riding on the bulldozer, and we've all seen bulldozer work in riparian areas. Well, that same guy who's having a good time, if he doesn't know you're there, he can run you over. But he can also run over your BMPs. Also, and probably more important to you, it's a legal requirement in your permit. Your SWP3 requires several pieces of information about inspections, maintenance, and corrective actions. You need to identify your inspector. You need to have your inspection schedule listed in your SWP3. You need to keep track of all your checklists or forms that you're going to be using in your inspections in your SWP3. And you need to list your specific procedures that you're going to do to take corrective action. So the inspector. This is an old DEQ guy, Robert Jemison. Some of you may know him. Your inspector needs to be somebody who's qualified. Now, your qualified inspector can come from your actual crew. Maybe it's you. Maybe you're the only guy. You can contract it out to somebody else who does it on a contractual basis. Whatever you use or whoever you use, they need to be qualified. And qualified, well, that implies training. So you need to make sure that whoever is performing your site inspections understands general BMP ideas and sediment and erosion control. You need to know that they know your specific site stuff, your SWIP, and it needs to be somebody who can figure out if something's not working or if it needs maintenance, and then can figure out how to fix it, all right? Well, which I just covered. And right here are some of our qualified inspectors. I think you recognize that guy. That's Joe Don. And this is Mike Cantrell from Del City. You can tell that he knows that silt fence needs to be installed properly because he's tugging on it to make sure it's trenched in. At the minimum, for the inspection itself, you need to make sure that you're looking at all the cleared areas, all graded areas, excavated areas, with or without stabilization, because you are going to need to look at your stabilized areas, not on the same frequency as your unstabilized areas. You need to make sure that you're checking all of your pollution prevention controls, and that are all of your controls, including pollution prevention. So those areas where you have stockpiled stuff, where you have fueling, where you have storage of materials, make sure you're looking at that too, and storage of maintenance areas. All right, at a minimum, you need to look at where stormwater is going to flow on your site. It's really handy, I find, if you take your site map with you around and look at where the water's flowing, and so you don't miss any areas. You want to check all discharge points And if there's a discharge, then you're going to have some extra requirements, including visual monitoring. You need to check that where you need stabilization, that it's been implemented and it's growing and working. You need to check to make sure that your controls are installed properly, working, and that they're working like they should. Right here, this is a construction entrance. You can't really tell anymore because it's been filled up. This is going to need some maintenance. It needs to be refreshed. Maybe you need to bring new rock in. Make sure you're checking that. Right here, we have a storage area, fueling. If you can tell right here, this is leaking. There's no berm area or anything. It's just running off. So check all these areas. At all of your discharge points, you need to check to make sure that you don't have any sediment or erosion occurring. You need to make sure that at the banks of the creek, you're not having erosion or sedimentation occurring in your surface waters. Once it gets in the creek, and Joe loves to say this, once it gets in the creek, it's gone. So it's better to stop it before it gets there. You need to check on your sheet. They'll say, do you need any maintenance? Is there any non-compliance? You need to make sure that you've written that down, that you show that, yes, there's non-compliance. If the discharge is occurring, identify all points where the discharge is occurring. Visual monitoring needs to occur, and these are all visual things: color, odor, solids, foam, sheen, that kind of thing. And there's actually a form that you can use to fill that out. And then, whatever you find, that's when you do your corrective action. Right here, this goes off to the storm drain to the creek, and there's nothing installed here. So this would be an area where maybe you want something along this area where the sediment's coming off. Maybe you need to institute a street sweeping or a get out there with shovels and clean it up kind of program. This is straw wattle. Straw wattle is actually pretty effective. It needs to be trenched in though, and it needs to be maintained. As you can see right here, it's been undermined though, and now water and sediment is coming right underneath it. This right here, back in the back, I don't know if you can make it out, there's a creek area, and here is some triangular silt dike, which is also a wonderful BMP. It did its job for a little while, but there wasn't enough. And so now all that sediment is headed down into that creek back there. Inlets, be sure you check your inlets. This is a good way to keep it from getting into your storm system. As you can see, dump no waste, it drains to the river. Here's one that's got a little sediment in the actual drain. And here is the sediment that's gone from the inlet into the sediment basin. Luckily, there was a sediment basin, but unfortunately, now a lot of his capacity's been taken up, so he's gonna have to perform maintenance later. That's a lot more costly to go in and clean out the basin as it would be to actually put in an inlet protection or some other controls upstream to keep it from getting in the pond. Check to make sure that all of your rock check dams. Joe was talking about how sometimes you see velocity dissipators being covered in sediment, and here's an example right here. They're gonna have to go in and clean that up and put that back. They could have put in some controls here to make sure that it didn't go down the side and erode into the check dam, and maybe they could have placed the outlet somewhere higher up like it's required to now. You want to make sure that your silt fence, because everybody pretty much uses silt fence, is put in according to specifications. You want to make sure it's trenched in and compacted. When I come, when Joe goes, when Bob comes, when Carrie, any of us come out to a site, we're going to check to make sure it's trenched in. And even if it looks like it is, if I can get my fingers under it, that's a pretty good indication that it wasn't installed correctly. We were talking about how silt fence, or Joe was talking about how it can be an effective control, and it can catch quite a bit. But when it gets to the 50% capacity, you have to pull it back out. So this, if you walked by your site and you saw this, if you were doing your inspection, then this would require maintenance. You would need some kind of corrective action. here, again, silt fence. It probably worked for a while, and then it got overcome. And this is going straight down into another velocity dissipation area here and into that creek. So this would be a great place to really focus some of your effort to make sure that sediment's not getting down into that creek. Is it installed correctly? I've said this before, but if it's laying over, then that's a good indication that it's not. Choosing the correct placement of silt fence. As you can tell right here, this is a pretty good placement of the silt fence. The water's coming, it's hitting where it should, and there's a pretty good little buffer there. Here, maybe not so much. It's pretty rocky. This is on top of a mountain in Oklahoma, if you call it a mountain. Probably not the best way, because a lot of what's coming down is boulders and that little gravelly stuff. And in fact, at this site, a big boulder went down through somebody's house, actually, from this particular site. Here's another application. If you're on a huge slope, is silt fence an effective BMP at the bottom of a huge slope? Anyone? No. It's not going to catch all of this sediment coming down. And you can see they're a pretty good rilling right now, right here, coming down the hill. And it's already been overcome. Joe said that if it's installed, it needs to be maintained. If you're not going to use it, if you want to have it removed, if you mark it removed on your SWP3, it needs to be taken out. This is wire backing, and here I am. You can't even, I can pull on it. It's in there pretty good, but there's no fabric to actually stop the sediment. Now, granted, in this particular, on the bottom, this particular situation, they put the silt fence uphill, so that it wasn't going to do any good anyway. So there's a lot to be said for walking your site with your SWP3, if you've had an engineer do it or somebody else do it, walking your site and making sure that it fits the site conditions and the size and the slope and the topography. Now this looks bad, not bad, right? It's got the backing and it looks like it's been trenched in, right? A little bit closer, and there's Joe's toe, because it wasn't actually trenched in. Okay, so we talked about looking at the other control areas, okay, and this includes concrete washouts. This is a big thing that we see a lot on construction sites. Usually people, or the concrete guys, they just want to wash out right where they're doing their work and just stick it right there on the side of the ground. So what's the big harm? You know, it's just concrete wash water. What does it matter? Concrete wash water has a pH of about 12, and so that can actually harm fish if it gets in the water. If it gets in the soil, it can make whatever contaminants are in the soil worse because of the higher pH. So that's something to realize. This one is actually built correctly. It's full, and somebody didn't actually, wash out in it. But there's a sign that says where it is, and it needs some maintenance. So we talked about looking at maintenance and storage areas also. If you have areas where you have drums that you're using for storage of waste oil or fuel or oil that you're going to use, you need to be checking that area too and cleaning it up. This has obviously been a problem for quite a while. It's not burned up. It's just sitting on the ground. And over here, somebody has just thrown down used oil cans just right there on the ground. Up here, more storage of leaking stuff. So look at your SWP3 and follow whatever pollution prevention measures are in there. You're going to have something in there, whether it's cleaning up the soil or making sure that your drums are removed or berming the area or pulling them out as they're done. So just make sure you're following it. You want to check all areas where you have discharge. So sometimes they're hidden. Right here, the sediment is coming down through the grass. It's kind of eaten out right through there, and it's going into this creek right here. So be sure you're walking the entire site and looking at everything. It's really important. Here's another area where sediment has left the site. Now, this isn't in a creek, so this might be a place where you could go and remove the sediment before your neighbor got mad and sued you. Walking downstream. If you're looking and you think that maybe sediment's leaving your site, go on ahead and walk down the street and take a look, because here you can see sediment in this culvert right here. And the entire area of the site. It's really easy to stop where the asphalt is and the major construction's going on, but if you come a little bit past, you can see that there's quite a bit of erosion right here. It's huge. And that erosion has gone straight to this creek. And that is just mud everywhere. Check all the banks of your surface waters. As you can tell, it's already hit the creek here, and there's more erosion here. All discharge points. So this is a site in the metro area where they didn't have any kind of controls along here because it was concrete. They didn't think they needed anything. But when you come over here and look, where the rainwater has gathered, it's discharging onto the post office's parking lot right here. So that's going to be a discharge you're going to need to look at and make sure you're not getting sediment or other pollutants, because what was actually in this water was oil. This particular machine right here was leaking into this water, and it was going right off site. All right, so you've done your site check, you've done your site inspection. Now you need to fill out your inspection report. Your inspection report needs to be completed within 24 hours of doing the site inspection. You have to have the date, the name and title, the summary of the findings. You have to have what you use to determine if it were a weather-determined event. So if you go out because it's a ½ inch of rain, did you use a rain gauge? What was the reading? Did you use a weather station? And what was the reading? And if you can't go to an area because it's dangerous, like Joe said, then you need to document that too. Every inspection, just like every piece of paper that you keep in your SWP3, has to be signed by the duly authorized representative. Again, you're certifying that you're not making stuff up, so make sure that's in there. In your SWIP, you want to keep copies of all your inspections so that when we come out, you can pull them out and we can look at them and make sure you're doing them correctly. Or make sure you're signing a bunch of blank copies and just appending them to the back. This right here, this is an example of just a site checklist. This is at the military housing privatized portion of Fort Sill down in Lawton. They contract with a guy who comes out and does just a little site check, and then he goes back and fills out an inspection form, and they work together to clean it up. This is EPA's actual example of a construction inspection form. The city of Lawton has put together from their new template one that just has OKR 10 information, and Jeremy, raise your hand, Jeremy, said that he would be happy to share that with anyone. And he's going to share it with me, so if you want it, you can contact me and I'll share it with you. Anyway, but this has all of the basic information that you need. The project name and all the general information, what kind of inspection is it, has it rained, that kind of thing. Then a list of all the BMPs that you have in your site map, in your SWIP. It goes on to specific overall site issues that you might run into, the slopes, are your buffers in place? Do you have the right BMPs, perimeter controls, discharge points, et cetera, et cetera. And then finally, you have the certification statement. So this one's fine to use too. And here's the certification statement again. We keep hammering on this because it is a big point. People have gotten in a huge amount of trouble for falsifying documents, and this is an important part of your SWIP. It's part of the permit, so make sure it's taken care of. So the frequency. How often do you have to inspect? Well, at a minimum, according to the permit, you have to inspect once every 14 days and within 24 hours of a ½ inch of a rainfall, and if you have a discharge from snowmelt. A lot of people don't think about that particular thing because it only comes during the winter. But if we do have snowmelt and it's caused a discharge, then you do need to inspect within 24 hours. Now, if you have an area that you've stabilized And that can be vegetative or non-vegetative. If you have an area that you've already stabilized, you can reduce that frequency to once every month, unless you start work again. If you start work again, then you have to bump it back up to once every 14 days. Of course, as Joe said, you can always make that less. If you want to do it once a week, that's fine. Just say what you're going to do in your SWIP. Some SWIPs that are just kind of handed down say once every 7 days. And we have run into cases where the SWIP says once every 7 days, but the inspections are only being conducted once every 14 days. Again, just make sure they match. Whatever you're going to do, put it in that SWIP, and then follow it. This is snow melt. And these are examples of stabilization, no construction's going on for at least 14 days. This is also at the privatized military housing at Fort Sill. All right, so you've done your inspection, you found out that your construction entrance needs refreshment, or you found out that your contractor didn't put in your silt fence correctly, or you found out that nothing's been put up. When that happens, then you need to do a corrective action, and it's required within 7 days of finding this out. And this also includes the special cases of the asphalt batch plants. So if there's a monitoring exceedance, there has to be a corrective action. When the corrective action is necessary, then you also have to create a corrective action report, and that has to be created within 24 hours. You have to put on this report the triggering condition, the nature of the condition, and the date and time it was identified, as well as how it was identified. Here's an example of EPA's corrective action form. As we said, the date the problem was first occurred, the time, today's date, the name, and then this has, these are specific things out of the permit as to what triggered the corrective action, whether it was because nothing was installed or something needed to be maintained, etc. You have to put a description, and then you have to come up with your deadline. If you can't do your corrective action within 7 days, there is some leeway, that's fine, but you do have to come up with another date, and then you have to describe why you can't meet that 7 days. You know, we can't get gravel shipped in within 7 days, whatever it is. And again, certification statements. Everything that goes in the SWIP, everything that goes with the permit has to be signed and certified by a duly authorized representative. Don't forget to look at all your inlets. This one's pretty easy to correct because you can just lift it up and clean it off. The other one, you have to pull out all that hay and reinstall. Now in this case, you know, maybe what you need to do, since you're getting it in the street, and that's quite a bit of sediment there, maybe what you need to institute is a different kind of street cleaning program. Maybe you're doing it as needed. Maybe you need to start looking at changing it and doing it once a week. Or maybe you need to get people with shovels out there ever so often to make sure that this is not occurring. You find that your silt fence isn't installed correctly. Well, A, you probably paid that contractor to install that silt fence. So I would call him up and say, hey, why didn't you install this correctly? Come fix it right now. Don't forget to document in your corrective action report. This is another instance where you need corrective action because nothing's been installed. This is the road and this is the graded area. It's kind of hard to change. All right, so here's an example of inlet protection that's not working. As you can see, it's going right in. The silt fence has fallen down. And here is an example of an appropriate inlet protection. What they've done here to help keep the sediment from coming over the curb is they've dug a little bit of a sediment trap right before the curb. This is also at Fort Sill. Within 7 days of the trigger event, a record of the following has to be completed. Any follow-up actions that you've taken when you're reviewing the design, the installation, or maintenance controls, and you got to keep all the dates with it. The summary of any modifications that you're making or that will be made with the dates that they either have been made or will be made. And then finally, a notice of whether you have to update your SWIP, okay? When you're updating your SWIP, don't forget your site map. It's really important. As you can see right here, this inspection showed that a stockpile was placed right outside of the silt fence, and the ditch that they have dug up has not been stabilized either. And here, the silt fence is overcome, although they did install that pretty well with the J-hooks. This is an example. These are two examples of site maps. This is from Concern, color-coded, dated, initialed. Now, they keep this on a wall. They have one that they use to walk around and make notes on, and this is on the wall so that they can keep track of everything all together. And this is in Elgin. He's filling out his site map right at the site, and that's fine too. Record retention. You have to keep all of your records from the start date of construction to the date that you have final stabilization. And then you need to keep all of those records somewhere in your corporate office for 3 years, according to EPA. You need to keep a copy of the SWIP at the construction site or at a place that's locally accessible. So locally accessible, well, that means, like Joe was saying, within a reasonable amount of time, you can get it to the site. As you know, you have to keep a map, an actual sign at your site that has all of the information. Well, on this sign, not just that, you have to put where the SWIP is located, okay, and how we can get a hold of it, how we can see it. If you want, some people do this. They leave a little box out there at the site, if you're not going to be there all the time, with the SWIP in it. That's acceptable too. You need to have all of the required documents in the SWIP, the site reports, the maps, corrective action reports, any monitoring results. Keep it in a binder. We usually like a binder because it's easy. You can pull it off the shelf and hand it and look at it. It's easy to keep track of. Special circumstances. We talked a little bit about impaired waters and RWs and ARCs. The big difference with site inspections for those particular areas is that the frequency has increased from 14, once every 14 days, to once every 7 days, but you still have the requirements of within 24 hours of the half-inch rain or within 24 hours of the discharge from snow melt. This is a map of where the outstanding resource waters are. And here's a little bit closer view. I think most people are at least familiar with the Illinois River area. And this is, again, a direct copy from the art viewer, which I think we're going to get to see, right? The GIS with the Aquatic Resources of Concern. And as Carrie mentioned, you know, the Red River's gone, and there's a couple of other areas that are missing from it, which is a good thing, because that means water quality's gotten better. And so they're off the 303 list, and there aren't species that we have to worry about. I hope it's not because they're dead. But they're not. We don't have to worry about it. All right, so my final set of special circumstances are concrete and asphalt batch plants. We've talked a little bit about this already, but at these two particular kinds of situations that might occur at a construction site that are included in your OKR 10, the comprehensive inspections of the site have to occur once per year, which is the ACER. You include it with the ACER by a qualified inspector. The scope of inspection, the name of the inspector, the date, and the observations. Again, sent to DEQ by March 1st, and corrective actions are required within 14 days of discovery. And this is just a picture of one. Quarterly visual monitoring is also required. So if you have discharge, you need to examine all the discharges at each outfall unless they're similar, which you have to, if you are going to say that they're similar discharge or just outfalls, then you need to explain how they're similar. It needs to occur during daylight, normal working hours, within the first 30 minutes of the start of discharge, greater than 0.1 inches, and 72 hours after the last event. Now, if your rain's going on at night, you don't have to worry about it. It's when you're at work. And then you're also going to keep this in your SWIP, okay? And this is the back of a concrete batch plant. Now, this wasn't covered under OKR 10. This was under a general permit, a mobile batch plant. But it's really important when you're doing your inspections that you check the entire area. And this is an example of what the quarterly monitoring observation might look like. Your color and extent, you're going to be looking at it. Is it clear, yellow, red, etc.? Do you have an odor? Is it clear or turbid? Do you have solids, etc.? Asphalt batch plants, like Carrie mentioned, are a little bit different. They actually have numeric effluent limitations. Those are for total suspended solids, oil and grease, and pH. It's a yearly grab sample, and you have to send the DMR by March 1st. Again, keep it with your SWIP. Everything stays with your SWIP. And that's it. Do you have any questions? Yes, Jeremy in the back. Just a minute, Jeremy. Wait. All the way in the back, Mickey.
Jeremy, can I have a copy of your inspection report?
On the grab samples for the discharge on the monitoring, if you have a site that's going to run off to a large detention or retention structure and it does not ever actually discharge out of your site, do you have to take a sample for the visual monitoring? Is that discharge when it leaves your site?
It's discharged when you leave the site.
So
when you leave the site.
when you leave the site. So if you don't ever have a discharge, there's no monitoring for
Then
that?
there's no, yeah.
Okay,
Exactly.
thank you.
Oh, yeah, good point. You do need to keep a discharge monitoring report that says no discharge. So those discharge monitoring reports are required monthly. So if you don't have a discharge, then mark no discharge, okay? Any others? No? All right. Thank you.